Hi guys, I'm going to go over this science packet with you. This is the one that is about earthquakes. So this first article is just from News ELA. And so to do this one, you really just need to read the article and then you can work on the 4 questions that go with that article in the packet. So the first question asks you to select the paragraph from the section Discovering the Mystery that explains how scientists have predicted earthquakes in the past. I circled the word past because that's going to be important when you're finding the right paragraph. In this article, you have to go to the first page, and at the bottom it says Discovering the Mystery. That's the heading that you're looking for, but those paragraphs are actually on the back side of that page. So these are the paragraphs that you would be choosing from, these 4. And you'll notice I put the star next to that third paragraph, and there are some key words right at the very beginning. It says until now. So until now, scientists have studied earthquakes by measuring seismic waves. And so those words until now are a clue to tell you that this is how they've done it in the past. And so that is how I would decide for number 1. So I would say for question number 1, it's paragraph number 3. It explains how up until this point, this is how scientists have predicted earthquakes. For question number 2, which sentence from the section The Dangers of the Faults describes the challenges scientists face while drilling at faults? So the dangers of the faults are back where we left off with the last question. So it's the next section down, the dangers of the faults. And it says which sentence explains the dangers that the scientists face. So when you look at these paragraphs, this one talks about drilling at the dangerous faults. This one talks about the project in New Zealand. This talks about earthquakes in New Zealand. This starts to get into, it says drilling such holes, such deep holes, however, is not easy, but it doesn't exactly describe the dangers. Here it says many of the most dangerous faults are beneath the ocean, okay? But it doesn't exactly tell us what those dangers are. In this paragraph, it does. That's why I've got the star there. It says Tobin spent 7 weeks at sea last winter on a scientific drilling ship. Its name is the Chiku, maybe? Chiku, I'm not sure how to say that. On the ship, they braved harsh winds and waves as high as 30 feet. And so that is the part that jumped out at me. So that's pretty specific. So what are the dangers? Well, they're out at sea, there are harsh winds, and there are waves as high as 30 feet. So when I flip back to question number 2, that is choice C. There are harsh winds and high waves. For question number 3, it says, what is the main idea of the article? So without even reading these 4 choices, this article was all about earthquakes and scientists finding ways to predict them. One of the things that they really pointed out is scientists are able to study earthquakes, but not until after they happen. It's very difficult for them to predict when they will happen. So looking at the choices, scientists are drilling at some of the world's most dangerous faults to be able to better understand and predict earthquakes. So right away, that choice is jumping out at me because that's really what this article talked about. And then for question number 4, which sentence from the article is most relevant to the main idea? So again, if this is all about drilling to learn more about earthquakes so that the scientists can better predict them, which sentence references that? Which sentence goes along those lines? So geologists study rocks and how the earth was formed. This really was not about how the earth was formed. The project in New Zealand is called the Deep Fault Drilling Project. So that's an important project. That project is helping with this main idea, but knowing that it's called the Deep Fault Drilling Project, I would not say is the most relevant. Tobin spent 7 weeks at sea last winter on a scientific drilling ship. That's a great detail. Again, I'm not sure that's the most relevant to what this article was about. Again, this article was about studying the rock beneath the surface layers of the earth so that scientists can predict when earthquakes will happen. So scientists from the University of Wisconsin-Madison are taking samples of rock from faults in Japan and New Zealand. And so I would say that's the most important for this, because those samples are what they're studying in the hopes of predicting earthquakes in the future. Once you finish this, the next section in this packet goes with Brain Pop. And so this is just a related reading, but you're not able to do the questions on the back of this sheet unless you actually go to the Brain Pop video. So I want to show you, if you go to Brain Pop and you search the word earthquakes, it's this first video right here. So you do have to watch that in order to be able to answer the multiple choice questions on the back. So I'll take a look at those with you. The first question says, what's the main cause of most earthquakes? And that is, the video will tell you, it's pressure from within the Earth's crust. No, I'm sorry, that's not right. I'm reading the wrong one. It's this one, changes in temperature. And those changes in temperature cause the shifting. It's in the mantle. It's not in the crust. That's not correct. It's the changes in temperature in the mantle. Earthquakes start below the surface of the earth. Question number 2, which of the following is a true statement about tectonic plates? And tectonic plates are not located in the core. They are not only below the surface of the ocean, or located below the ocean. They're located below continents and ocean. They are not in the molten layer. They are actually just above that. But all of Earth's land mass does rest on the tectonic plates. All of our land masses are on one of the tectonic plates. Number 3, the weight of the lithosphere keeps the mantle in a semi-solid state. What can you infer from this? So the mantle is very hot, and you would think that it would be liquid because it's so hot. It should be melted. But it's in a semi-solid state. They explained in the video, it's sort of like clay. And the reason it's like that is because there's so much pressure. The pressure that is on the mantle is keeping it from being completely liquid. It keeps it semi-solid. And so what can we figure out? Well, this one's a little bit hard, but they all have to do with pressure. And it's C, pressure lowers the melting point of solids, which means in order to get it to melt, we would need, raises, we would need an even higher melting point to get the solid to melt. And so this pressure is making it harder for it to melt into a liquid. So we would actually need a higher temperature. For number 4, you have to sequence these layers of the earth from highest temperature to lowest, so hottest to coolest. And so the further in to the earth you go, the hotter it gets. So the hottest one, the highest temperature, would be the core. The next one would be the mantle. And then the last one, or the coolest, even though it's not really cool, would be the lithosphere, because that is the outer layer around the mantle. So it would be choice C. What can you infer from the fact that tectonic plates are always moving around? So we know that the tectonic plates are always in motion. The video explained that the motion is very, very slow and we can't feel it. But what we can figure out, and we know this because we had made that Pangea puzzle, the shape and location of the continents have changed over time. It's a very, very slow movement, but over time, we saw from making that puzzle that the continents have shifted. Why are surface waves more destructive to buildings than the initial seismic wave in an earthquake? So the first thing you feel the first thing that you start to feel in an earthquake are the seismic waves. They come from way below the surface, and then they rise up and they turn into surface waves. And the reason the surface waves are so destructive is because, let's see, it creates more sustained motion on the surface. The movement way down below the surface of the earth is not going to be felt as much to people or the objects that are on the surface, but once they rise up and they come to the surface, it's going to make that motion that will feel and can be destructive. This instrument they showed you in the video, this is how they measure the earthquakes. It's called a seismograph. Why are faults sometimes referred to as active boundaries? Well, the faults are where this activity takes place. So it says they're all volcanically active. That's not true, not all. They serve as boundaries between nations. No, not at all. The Earth's crust shifts on either side of them, or people must actively avoid faults to escape injury. So for D, there was no talk about that at all. It's C. The crust shifts on either side of these boundaries. In the phrase, the Richter scale measures the potency and duration of seismic waves, what does potency mean? So potency, this is a vocabulary question, and what it means is the strength, like how strong the waves are. So potency means how strong the earthquake waves are, these seismic waves, and duration means how long they last. And then for number 10, you have to know a little bit of geography. In the video, they explained that the west coast of the United States is most prone to earthquakes. There's a lot of earthquake activity along the west coast of the United States. So you have to know where all of these cities are located. And Los Angeles is in California, and California is on the west coast. Obviously, we know where New York is on the east coast. Miami is down in Florida, so that's also on the east coast of the United States. And Chicago is in Illinois, and Illinois is more toward the central or eastern side of the United States. So the only city that's on the west coast is Los Angeles. On this next page, I just filled in the blanks. These are really just finding the words in the video. And for some of these, I went back, I replayed the video a couple times and just listened until I got the right word that they were looking for. And so I'm just going to show them to you. And again, just go into the video and you'll see that you can find these words. For this one, this says it's further research. I don't need you to do that. They want you to do your own research. It's not in the video. It's not in the reading. They want you to explain how the Richter scale works. So if that's something that's interesting to you, you can go ahead and do that research and you can write about that. You could even share it with us if you want to in Google Classroom, or send it to me and I can share it with everybody. But I'm not expecting you to do that.